Hello everyone and welcome to today's programming video. In today's video, we will solve the Leetcode problem called maximum subarray. In this problem, we have been given an integer array, nums, and we need to find a contiguous subarray, and that has to have at least a single number. And the condition which it has to fulfill is that it has to have the largest sum, and we need to return this sum from our implementation. So a subarray is nothing but a contiguous part of an array. So for example, if we look at this array here, then we can say that -2 and 1 and -3, they can form a subarray, but -2, 1 and 4 can't form a subarray because they are not contiguous. Let's first try a brute force approach and then follow it up with an optimal approach to solve this problem. So we have been given this array, and if you want to calculate the sums of each subarray starting at index 0, we need to calculate the sums of subarrays at index 0. First one is single element at index 0, then the next subarray is this, which is 0 and 1, so we add up all the numbers between them. Then the third subarray is 0, 1, 2 indices, and we add up all the numbers again here. So we keep on doing that and till the last one, and then we find which is the maximum sum amongst each of these individual subarrays. Then we have to move on to index 1. So we take the first element as the smallest subarray. Then we take the next subarray, which is 1, 2. So that's 1 and -3. We add them up. So we keep on doing that till we go till n-1 again. So we then find which of these subarrays has the maximum sum, and then we again compare it with the maximum sum we had found at index 0. So this approach is going to be rather inefficient because we have to loop the array once to get to each index, and then within that loop we need to get the subarrays for that index. So it's going to be O of n square complexity. Now a better and efficient approach for solving this problem is what is called as the cadence algorithm. We can use dynamic programming technique and break the problem into smaller subproblems. So the main gist of this algorithm is that we look at each index and establish what's the maximum subarray at this index. So when we're calculating the max subarray at index I, we can reuse the sum of max subarray at index I-1 with the current element rather than calculating it again. Let's see what the max subarray will be for each of the elements. So our base case will be the max subarray at index 0. So I've used the short form MSA to stand for max subarray. So the max subarray at index 0 will be -2, and this is our base case. So now let's look at the max subarray at index 1. So according to this algorithm, we can use the max subarray which we have already calculated at the previous index. So how do we use it? So if we look at this index 1, so we want to essentially find the max subarray between this one and this one. So we need to add the value or the number, the current index, so that is 1, and add the max subarray value or the sum of the max subarray at the previous index. So that is -2. And that gives us -1. Now, if you look at this, this -1 is actually less than the value of the current element that we are iterating over. So we need to actually take the greater of the two values and not just the sum of the current value and the max subarray sum at the previous index. So instead of just doing this, we have to calculate the max, and that will be the max between 1 and -1, and that's actually 1. So the max subarray at index 1 is 1. The reason why we have to take 1 and compare it with the sum of this element and the previous max subarray is that because this on its own is also a subarray. So now while we calculate the max subarray at each index, we need to keep track of the maximum sum of the subarray so far. So we can use another variable called max so far, and we'll initialize it with the value at index 0 to begin with. So that will initially have -2. When we calculate or when we start iterating over this array and we start calculating the max subarrays for every index, we will check if we have found a larger value. So in this case 1 is greater than -2, so we will overwrite that number with 1. Okay, now let's go to index 2 here. So the max sub array at index 2, what will it be? It will simply be the the greater of the two between the value at index 2, which is -3, and the sum of the value, which is -3, plus the max sub array at the previous index. And the max sub array at the previous index was 1, and that gives us -2. So between -2 and -3, -2 is the greater. Now if you see here, we have gotten a bit more efficient, that we're not recalculating the max sub arrays at all the previous positions, right? We're storing the max sub array in a variable which we can call as MSA, and we just need the previous or the max sub array at the previous index. We don't even need the max sub arrays at all the previous indices. Now if we compare -2 and 1, 1 is still bigger, so we'll not overwrite it, we'll leave it as it is. Now let's go to index 3. So max sub array at index 3 is the greater of the values between the value at 3, that is 4, and 4 plus the max sub array at the previous index, that's -2. And obviously the greater of the two is 4 here. Now we again compare 4 and the max so far, which is 1, and we see that 4 is greater than 1, so we overwrite that, store a 4 there. So far so good. And let's go to the next index here. At index 4, what will that be? So it will be the greater of the two values between the value at index 4, which is -1, and the sum of the current value -1 plus the max sub array sum at the previous index, which is 4, and we will get a 3 here. Obviously 3 is less than 4, so we will not change anything here. We go to the next index. At index 5 will be the greater of the two between the value at index 5, which is 2, and the sum of 2 plus the previous max index, which is 3, which is 5, so we get 5. And now 5 is greater than 4, we overwrite it, we store a 5 there. Going to the next index, which is index 6, and the max or greater of the two is the value itself 1, between 1 and 1 plus 5 at the previous one, and we get 6, and we overwrite 6 here because we overwrite the max so far because 6 is bigger than 5. And the next one is index 7, and we check if it is which one is greater. So the value at index 7 is -5, and we add -5 to the previous calculated max sub array, and we get 1 because -5 plus 6 is 1, which is greater than -5. We don't override the max so far. We go to the last index, index 8, and we check the greater of the two between the value at index 8, which is 4, and 4 plus the previous max sub array sum, which is 1, and in this case it's 5. Now 5 is less than 6, so again we leave max so far equal to 6, and we finally return the max so far value. So this here is the value we need to return from this function, which we will now implement. So we will first define the max sub array variable, and we'll use the first element in the array nums as the base case. And we also want to keep track of the maximum sum so far, and when we calculating each of these subarray sums, we need to know which is the maximum. So we'll define another variable called max so far, and also initialize it to the first element in the nums array. Now we'll start iterating the array from index 1 position. And as I mentioned earlier, we need the max sub array value, or the sum of the max sub array, the previous index, which is what MSA holds. So every time we will simply overwrite it with the new value of the max sub array. Now that we have calculated the max sub array for the current index, we need to check what is the bigger of the two, whether it is the max so far or whether it's this current max sub array sum. And that's all there is to this for loop. It's a simple for loop, and we will calculate largest sum and we'll return it after the for loop finishes. Yes, as you can see, this is implementation with complexity of big O of n, so it's a linear time complexity. We have achieved the result with a single pass of the input array. Thank you very much for watching. I hope you found this video useful, and please do remember to like and subscribe. Thank you. Bye.